Okay, unfortunately I started the video a few minutes into the actual lecture, so we're going to have to stall for a minute and talk about what we did. That there's a universal gravitational pull, um, and that all things that usually when we talk about gravity here on Earth, we talk about things moving down, and it's not really what happens. What happens is that things are pulled towards the center of the massive object. Now, close to the Earth, that acceleration is 9.8 meters per second squared, or 32 feet per second squared, near the Earth. However, but that's not really what gravity is. That is just a localized phenomenon for us here on Earth. The further you go away from the Earth, you have other objects interacting with it, like, say, the moon, and the moon is always directed towards the center of the Earth. And so what we like to think of as down is actually towards the center of the Earth. The moon, however, has a different value for its gravitational acceleration because it is much further away from the Earth. Now, that's a concept that we're going to get into a couple units from now, but that's an important distinction when we're talking about gravity. Now that we have this constant, this 9.8 meters per second, we can now put that value for g into all of our previous acceleration values and all the kinematic equations we've already covered over the last few days. So our first one is going to be velocity final equals velocity initial plus g times time, but we also plug it into the other ones. So our final velocity squared equals our initial velocity squared plus 2gd instead of 2ad, and our displacement equals our initial velocity times time plus 1/2 gt squared instead of 1/2 at squared. Our lecture here is going to talk about our different types of graphs that we have. And the first graph that we have is our position versus time graph. And we've already dealt with this to some degree, particularly on Khan Academy, where our position versus time graph gives us, when we look at the slope of our position versus time graph, that gives us our velocity. That is our meters that we're traveling for every second that we're moving. And if they're straight lines, then it's really nice because we can just figure out the slope, and they are, and that gives us our velocity. Okay, the next kind of graph is our velocity versus time graph, and we do two things. One, if we look at the slope on this one, then that gives us our acceleration. But if we look at the area under the graph, then that gives us our displacement. And that's how far we've moved. If you think about it as velocity times time, that gives us our displacement. And so what happens? So if we have a changing velocity, however, what winds up is that what happens underneath the curve gives us our displacement. So we find the area underneath the curve, and we get our total displacement for that total amount of time. Our third type of graph is the acceleration time graph, which gives us a little bit less information, or is a little bit less interesting than the velocity time graph, until we get up into higher levels and we start looking at curves on this and how this is actually changing. But we don't generally have slopes if we have constant accelerations. So we have flat areas. But those areas, the areas beneath the curve, represent velocity again, except it's not velocity quite. It's more the change in velocity for an acceleration graph. And so if we're looking, and because we have a positive acceleration sometimes, or we have a negative acceleration sometimes, and we're looking at the change, that we're actually going to be getting positive values, and then we're going to be adding negative values, and then adding positive values. And so what happens at the end of each block is that we have, when we start adding the areas together, we start finding what our final velocity is after those acceleration effects. So what we're going to do now is we're going to go back and look at our other graphs, and we're going to and we're going to uh, find various things in regards to these graphs. So for the position versus time graph, we're going to find our velocity at places A, B, C, D, and E. All right. Then for the velocity time graph, we're going to find two sets of things. We're going to find our acceleration for each stretch of the graph, and we're going to find our total displacement as exactly as possible by finding the area underneath the curve. And then for the acceleration graph, we're going to find the total velocities of each segment and then the final velocity of the entire graph. Unfortunately, the video here stopped flowing and it started getting very, very choppy, like one scene change every 10 seconds or so. So I'm going to have to stop the video here and figure out what's going on with my recorder. But this is the gist of the lecture, and if you have any questions about the rest, go ahead and write a comment or come see me after class.